Now let's work a POQ problem. So here we have a production situation where we have a demand for 30,000 units. So given demand is 30,000 and we are going to assume a 300-day work year exclusive of holidays and weekends and so on. So 1 year is 300 days. So which means our demand rate is 30,000 divided by 300 will give us 100 per day. And we are given holding cost of $50 per unit per year. And setup cost is $150 per setup. And we are given production rate is 300 per day. So here let's make sure note P is greater than D. So that must be true for POQ to work. So the first question is what is the optimum production quantity? So POQ formula is then you plug in the values to 2 times 30,000 times 150 divided by 1.5, 1 minus 100 over 300, and that is equal to 3,000. And B, we're going to have to calculate various quantities related to this POQ. So the first one is I sub max. So that is the maximum inventory level. So the maximum inventory level is, so if you remember, maximum inventory level, so that's your I sub max. So that is given by P minus D. So that is the rate at which inventory will go up. P is the production rate, the rate at which inventory is coming in. D is the rate at which inventory is going out. So P minus D is the rate at which inventory will go up, divided multiplied by Q over P. So this is the time period for production, T. So this gives us 300 minus 100 times 3,000 divided by 300. So that gives us 2,000. So that is our I sub max, maximum level of inventory. Now next is average inventory. So average inventory is I max I sub max over 2. So that is 2,000 divided by 2 is 1,000. Annual total cost is annual order cost or setup cost plus annual holding cost. this is that is equal to annual setup cost is due over Q times S plus I sub max, so this is not Q over 2, I sub max over 2 times H for annual holding cost. So this is equal to 30,000 divided by 3,000 times 150 plus I sub max is 2,000 divided by 2 times 150, so that is 1,500 plus 1,500 is $3,000. So once again you see these two costs are equal. That's the foundation upon which EOQ or POQ is modeled. Okay, next, number of batches per year or number of orders per year. So that is annual demand over Q. That will give us how many times you have to place the order. So that is 30,000 divided by 3,000 will give you 10 batches or 10 orders. The next one is time between orders. Time between orders is Q over D, so that will give you 3,000 divided by 100. Okay, we calculated D to be 100, so that will give us 30 days. Then finally, the duration of production run. How long will one production run last? Duration of production or length of production is how many units we have to produce and what is the rate at which we will be producing. So that is 3,000 divided by, we will be producing at the rate of 300, so 10 days. So the total time between orders is 30, so every 30 days we have to place an order. Once we place an order, it will take 10 days during which the production will take place, and then there is 20 days where there will be no production, there will only be consumption.